Hi everyone and welcome back. In this video I'm going to be going through two of the textbook questions that involve equations that have a divisor, a single divisor on each side. So let me show you how to handle that. Okay, so first thing you want to do is actually to get rid of these divisors. We can't get into what's on top of this until we can get rid of what's on the bottom. So that's the first thing we're going to do. And the way that we do that is by adding a numerical coefficient outside of the implied brackets on each side, and it has to be the same number. So the way you choose that number is by determining a common multiple between the two divisors. So 2 and 3 can be multiplied to get to 6. So 6 is divisible by both 2 and by 3. So we're going to put that as our numerical coefficient. 6, 6. 6, so then we use that to get rid of the divisor. We actually divide it out. 6 divided by 2 leaves me with 3 here. 6 divided by 3 leaves me with 2 here. So what I'm left with is 3 times 2x minus 1 equals 2 times 2x plus 1. So now I've got a question with brackets, so next thing I have to do is get rid of those brackets using distributive property. Okay, times it by the first term, times it by the second term. 3 times 2x gives me 6x. 3 times negative 1, mismatch, gives me negative 3. Next, 2 times 2x gives me 4x. 2 times positive 1 gives me positive 2. Okay, next step. Switch back to a blue here. I need to group my variable terms. So opposite of a positive 4x is a negative 4x, gone, minus 4x over here. 6 minus 4, left with 2x minus 3 on the left side and a positive 2 on the right side. Okay, so now regular two-step equation. Cancel the constant first. So opposite of subtracting 3 is to add 3, but I must do the same thing to both sides. So on the right side of my equal sign I'm left with 5. On the left side I'm left with 2x. Opposite of multiplying x by 2 to divide it by 2, but I got to do the same thing to both sides. So I think in the textbook they even stop here and they just say x is equal to 5 over 2. Best practice though, you shouldn't leave your fraction improper. So instead, how many times does 2 fit into 5? Twice, that gives me 4. So I'd be left with 2.5. Or I know some people, so that's fine as a final answer, or I know some people actually divided this out. That's fine too, so you would just end up with 2.5. Same answer, okay? You've just expressed it in a different way. Both of those would get you full marks. No problem there. Last one, 11D. Let's take a look. What do we got here? We've got 6m minus 3 over 5 equals 4m minus 1 over 3. Okay, so same thing again. We're going to cancel out the divisor by assigning a numerical coefficient outside of the implied brackets. We need a number that's divisible by both 5 and by 3. So that could be 15, right? Those can be multiplied together to get to 15, so I know for sure that'll work. 15 divided by 5 leaves me with 3. 15 divided by 3 leaves me with 5. So here's what I'm left with. 3 times 6m minus 3 equals 5 times 4m minus 1. Next, get rid of the brackets using distributive property. Times by the first term, times by the second term. 3 times 6, 18m. 3 times negative 3, negative 9. 5 times 4, 20m. 5 times negative 1, negative 5. Now the variables need to be on the same side. Opposite of positive 18m, minus 18m, gone. Same thing to the other side. 20m minus 18m leaves me with just 2m's. Okay, careful, careful. If you're left with a subtraction sign, you must bring it down and treat it as a negative. So that's negative 9 is equal to 2m minus 5. Regular two-step equation now. Always start by canceling out the constant. Opposite of minusing 5, plusing 5, gone. That's 0, but I have to do the same thing over here. Negative 9 plus positive 5. It's a battle. Who's stronger? The negative by how many? By 4. Negative 4 equals 2m. Last step to get m alone. Opposite of multiplying m by 2 is divide it by 2. So I'm left with just a single m. But I have to do the same thing to the other side. Negative 4 divided by 2 leaves me with negative 2. Box it up. Final answer. Thanks so much for watching, guys. See you in the next one.